Hi guys, this is Maverick Paul, the Chemistry Guru. Now in this video, we want to run through the suggested solution for 2019 A-Levels H2 Chemistry, Paper 1, Question 9. Alright, Question 9 goes something like this. X is a compound made from two period 3 elements. It reacts with HCl aqueous to give a solution, and a gas is shown. So I have an unknown X with HCl aqueous. You split into two portions. One is solution Y. The other one is gas Z. So for solution Y, when we add sodium hydroxide aqueous, I'll get a white precipitate, insoluble in excess NaOH aqueous. Now this will remind us very strongly of QA. So most likely this will be testing the presence of our metal cation, but we will confirm this in a while. Now for gas Z, if I react this with air, so this will burst into flames to produce two oxides, one of which is water. So one of the oxide is just water, we have already identified this, and the other, a white solid, which is insoluble in dilute acid or alkali. So the other oxide, which is unknown, insoluble in acids or alkali. Now, from which two period 3 elements could X be made? And I'm given four options. A is aluminum and phosphorus, B is aluminum and silicon, C is magnesium and phosphorus, D is magnesium and silicon. So effectively, I have two metals and two non-metals to play with. I know that the compound X will be made up of one metal and one non-metal, because aluminum is the metal, phosphorus is the non-metal, then magnesium is a metal, and silicon, it is the non-metal. So I know that X is made up of one metal and one non-metal element. Then the two metal choices, based on the options given, it is only between aluminum and magnesium. So it makes it a lot easier for us to do comparison. I only need to compare between magnesium and aluminum. Then for the non-metals, you notice we have something similar. I only need to compare between phosphorus and silicon. So I only have two non-metals to worry about, two metals to worry about. Now as mentioned, since we have to identify one metal and one non-metal, then very likely when we look at this test here, this is to test for the metal cation. Because if you look at the test here, it should remind us of QA. So we will refer to the QA notes in the data booklet to try to determine which metal cation will give me this observation. So what this also means is the non-metal oxide will have to be identified here. Because this is for the metal, this one must be for the non-metal. Of course, this test, it is not a QA test, or it is not a standard QA test that we can find in the data booklet, but you notice the question already tell me that I have two oxides based on this reaction of Z with air, one of which is water. So we don't need to care about water, it is already identified. We only need to worry about this white solid, so this non-metal oxide, which is a white solid, and it is insoluble in dilute acid or dilute alkali. So for this portion, what we will do is we will use concepts in periodicity to determine which of these non-metal oxides, is it silicon oxide or phosphorus oxide, which of this guy is insoluble in both acids and alkali. So we will talk about this subsequently. So let us settle the QA first, because I think this is a lot more straightforward. I can just easily pull this information from the data booklet. So from the QA notes, I only need to compare between Al3 plus and Mg2 plus. Now the observation that is given in the QA notes, remember we don't really need to memorize this. I can easily refer to the data booklet. Al3 plus, if you add sodium hydroxide aqueous, you get a white precipitate which is soluble in excess sodium hydroxide. Magnesium, Mg2 plus, if you add sodium hydroxide, it will give me a white PBT which is insoluble in excess sodium hydroxide. So the observation that is given in this question is white PBT, insoluble in excess NaOH. So comparing these two guys, obviously Mg2 plus will give me the consistent observation. I know that this metal should be magnesium, it is not aluminum. So at least we have settled and identified the metal. Now how about the non-metal? Again, we will focus on the properties involving this non-metal oxide. The question tells me that this non-metal oxide, it is insoluble in dilute acid or dilute alkali. So the two oxides that we have is either silicon oxide, SiO2, or phosphorus oxide, P4O10. So this is the phosphorus oxide that is insoluble. We will be using this guy, P4O10. Now comparing these two guys, both of them are non-metal oxides. We would expect non-metal oxides to be acidic. The difference between these two is silicon dioxide. It has strong and extensive covalent bonds between the atoms within this entire giant molecule. So the consequence is silicon dioxide, it is acidic, yes, but it doesn't have reaction with dilute alkali. It only reacts with very strong alkali or concentrated alkali. So in this case, silicon dioxide will give me a more consistent observation as compared to the question. If I look at P4O10, now P4O10 is acidic, so we would expect this guy to react with dilute alkali, undergo neutralization reaction or acid-base reaction. Obviously, these two non-metal oxides, since they are acidic, then they shouldn't react with dilute acids. So if I look at these two non-metal oxides, silicon dioxide versus P4O10, between these two, SiO2 will give me the consistent observation as compared to what is given inside this question. So we would expect this non-metal to be silicon. So we have already identified the metal and the non-metal. The metal will be magnesium, the non-metal will be silicon. So if I run through these options, the answer to this question obviously will be option D. Alright, so that was the discussion involving question 9. Question 9 is a little bit more interesting, correct? Because at the beginning, it looks like it is a QA question or experimental question. One portion of it, in fact, we will need to make use of the information from the QA notes to get the outcome. But the other portion involving the non-metal oxide, we actually just need to look at the properties involving our non-metal oxides, see whether it reacts with acids or bases. Again, this idea or this concept, we cover this under periodicity. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. Thanks for watching.